Welcome back to Smart Architectural Programming. In today's video, we'll be covering another topic in the Introduction to Java series. And we'll be diving deeper into one of the most powerful features of object-oriented programming, polymorphism. Keep in mind, this is the third video of Chapter 9 of our accompanying Introduction to Java book. So with that, let's push forward and understand what is polymorphism first. So, what is polymorphism? You might have heard of this term a lot in the tech circles, especially if you're learning a language and you're into the object-oriented part of the languages. So, polymorphism basically is derived from the Greek words poly meaning many and morph meaning many forms. So, instead of polymorphism, just think of it as what is many forms, right? It basically allows Java objects to take any forms depending on the context of which they're being used, right? Simple enough, but it is kind of quirky to, get it intuitively, considering we need to keep in mind that contextually certain objects in Java may take different forms or different results, right? So in Java, basically, this means that single reference types can point to different object types, enabling flexible and reusable code. We'll get to that soon. So hold your horses and let's push forward and understanding what is polymorphism more deeply. So the next part we need to understand is basically how we separate reference type from object types in Java, right? So in Java, when you create an object, you're working with two types, the reference type and the object type. Reference type is what the compiler sees the object as, and object type is what the JVM executes the object as at runtime. So let's look at a code to clarify this concept a little better. So as you can see this code here, we have animal, which is probably a class that we defined. Then we created called that new animal myAnimal and created an object using the dog class probably. So here myAnimal is declared as an animal. That's the reference type, but the object it points to is actually a dog. That's the object type. So here's what you need to understand. We're telling Java that animal is the reference that you need to keep in mind when you're creating myAnimal variable. But the object that that particular variable points to is actually a dog. That's the object type. So it's basically clarifying different roles here. So the separation basically allows Java to compile code safely while leaving room for dynamic behavior that might be needed at runtime. So what's next? We need to understand how polymorphism works in practice, right? So if you look at the code here, now that you see it, you'll see that we have covered two types previously. Now let's apply polymorphism in a real-world scenario to understand those two types in more detail. As you can see in the code below, particularly if we, after defining these two classes, let me bring out a marker here so I can pinpoint exactly what I mean. So after defining these two, this class of animal and this class or subclass of dog, we write this code in lines 13 to 14. Right? Animal A, new dog, A dog, make sound. So the output is bark, not generic sound, right? Why is that? Because make sound is overwritten. Even though A is declared as an animal, the JVM dynamically determines the method to run based on the object type, not the reference type, right? So the object type is here, which is dog, and the reference type is here, animal, right? So the animal is the class here and the reference type to the class here, while the dog is pointing to the object type, which is the subclass dog. So with that basic understanding, let's understand what method overriding is. So generally speaking, overriding is central to polymorphism. It allows a subclass to provide its own version of a method defined in a superclass. This ensures that behavior is determined dynamically at runtime, a very important trait in polymorphism. So let's break this down. It allows a subclass to provide its own version of a method defined in a superclass. Animal is the superclass. We defined a method in the subclass. The subclass, like the sound make sound function that we covered previously, overrided the make sound version of the superclass, which is animal. That makes sense? This means that behavior is determined dynamically at runtime, a very important aspect to the polymorphism we're covering in this video. So let's try to understand, because we might have heard of the term method overloading. So we need to, and we covered it previously as well. So let's try to contrast overloading with overriding and see if you can understand the difference between them. Because confusing overloading with overriding is very common. Overloading happens within the same class with methods of the same name but different parameter lists, right? As you can see. And as you can see in the code here, let's focus on the code here. We have add and double add, int add and double add methods in the calculator. When it's overloaded, based on the parameters ran when we call the function add, right? Whether we give it 2 ints or 2 doubles, right? Based on that context, either this add or this add would be selected. That's overloading, right? And it is resolved at compile time, not runtime. That's a key difference to remember. So overloading is compile time, same class, and static binding, and it's basically parameter-based selection between the similarly named methods within the same class. While overriding is runtime, it means that the subclass, which is part of a superclass, is overriding one of the methods of the superclass, to be more specific for the subclass, and it creates dynamic binding, not static. So with that understanding, let's push ahead into JVM, object type versus reference type usage. So you see that we mentioned reference type and object type in reference to what we were talking about earlier, right? So what is object type and what is reference type and its usage? Let's try to break that down. So when JVM runs your code, it checks the object type to determine which version of the overriding method to execute. This is known as dynamic method dispatch, one of the ways the JVM brings polymorphism to life. So let's look at this code here. The reference type tells the compiler what's allowed, right? The object types tells JVM what actually runs, right? So think of it this way. The reference time is the control. It controls what sort of dimensions or what sort of the data this variable is going to have. While the object type here determines what JVM, which is the compiler for Java, is actually allowed to run. Make sense? It would come intuitively as we move forward, but I think this is the most clear I could be with object type and reference type usage is within Java. So let's just put it this way, right? You hold a remote control, which is the reference type, and you switch out TVs, speakers, and projectors, which are object types. The remote has standard buttons, but each device responds differently. The abstraction is what makes large-scale Java applications scalable, flexible, and clean. So, if you found this helpful, hit the like button, subscribe to Smart Architectural Programming, and don't forget to check out our book, Introduction to Java, for more detailed example exercises and getting a much higher level of deeper dive into understanding polymorphism in Java. In our next video, we'll explore interfaces and abstract classes, essential tools to master advanced polymorphism in Java. Thanks for watching and keep coding smart.